All right, good morning and welcome to Master Talker online class. If today is the first day of watching our video, please click the subscribe button so that anytime we drop a new video, YouTube will notify you. All right. Now we want to solve some calculations that involves particulate natures of matter. We have already explained what we mean by particulate natures of matter in our previous video. Please, you can watch that. All right. Now, this question said, using this now, the answer, which of the atoms in the table are isotopes of the same element? Now, don't forget what isotope is. Isotope atoms that have the same atomic number or the same electron number or the same proton number but different neutron number, or rather different mass number, and that mass number is due to different neutron number, right? So if you look at it now, you see that number one, to answer number one now, you will look at it, you see that the atomic number here, P and S, have the same atomic number. An atomic number is something as the electron number or proton number. So have the same proton number, they have the same electron number, but different mass number due to the presence of what? Different neutron number. So therefore, P and S are isotopes. Isotopes. Right? Okay? P and S are isotopes. So number two, they said, number two, which of the atoms contain 18 neutrons? Which of the atoms contain 18 neutrons? Now, don't forget that mass number is equal to what? Atomic number plus neutron number. Okay, so now let's check the one that has the 18 neutron. So if we say what? If you have now 18 neutron, now how do you get the one that has 18 neutron? If you now say any of these atomic number, okay, now watch. Let's say, okay, so now what do we have now? We have that neutron number is what? 18. Now what do you add to this 18 in any of these atomic number to give you the same thing as the mass number here? You understand? So now, for example, 18 plus 8 is 26, and 26 is not here, so it's not correct. 18 plus 20 is 38, and this is not 38. 18 plus 17 is what? 35. So you see that what? R 18 plus 17 is giving us what? 35. So which means, or you can rather say that what? I hope you know that neutron number is what? Mass number minus what? Atomic number. So if you say now 35 minus 17, you have what? You have 18. So which means what? It is what? Element R that has neutron number. Therefore, this is number 2. Therefore, R contains 18 neutron. All right, so this is very simple. Now they now say that which of them is chemically unreactive? Which of them is chemically unreactive? Now, anyone that is chemically unreactive is the one that has the one that is saturated. Okay, the one that is saturated, the one that their shell is complete. So now, if you write electronic configuration of all these ones now in terms of KLM shell, for example, now this one is 2,6. Oh, it is not that. So let me check this one now. This one is 2,8, and the 8 is complete. So if you look at that, you see that this is the nucleus. I have 1, 2. Sorry, 1, 2. Then I have what? 3, 4, 5, 6, 7, 8, 9, 10. So, and this is what? K shell. And this is what? Okay, L shell. And don't forget that L shell takes the maximum of 8 electrons and it is filled. So anyone that is filled is called a noble gas. So they are what? Chemically unreactive. So you tell them that what? Element T is what? Chemically unreactive. All right. See, very, very simple. So the next one said that what? Which of the atom attains an octet structure by accepting one electron? Now, which of them we attain? Permit me to clean here. Which of them will attain octet structure by receiving one electron? Now, if this one receive one electron, it's going to be 9, and the electronic configuration of that P is what? 2 comma 7. Okay, that is 9. He has received one. Let's check for 20, which is Q, is what? 2 comma 8 comma 8 comma this is 18. If you receive one, it's going to be 21, which is 3. 21. Now let's check 17. R is what? 2 comma 8 comma 10. It's supposed to be 17. So if you receive one, it's going to be what? 18. You see that what? It what? Attain an octet structure when he receives one electron. So you now see that what? R R R attains an octet an octet an octet structure by accepting one electron. You see that? Okay. So now the last one now said what? Number 5. Number 5 now said, permit me to clean here. Number 5 now said, which of the atom forms ionic with R? Which of them forms ionic with R? And what is R? R has 17. So the electronic configuration of R normally is what? 2 comma 8 comma 7. So R needs who will give him one electron. All right. So let us write electronic configuration of the rest and see who can give him one electron. Okay. So if you write the electronic configuration of P will give you what? 2. In fact, it's even better you write the electronic configuration of everybody so that you can easily from there be getting what you want. So this is 2 comma 6, right? 2 comma 6. Why this one is what? YQ is 2 comma 8 comma 8 comma 2. Y S is what? The same thing as this, 2 comma 6. And the other one is what? T is what? 2 comma 8 comma 2 comma 8. So which of them? If you look at this, because of the fact that this person wants to receive one electron, he is a non-metal. And since he's a non-metal, so we need a metal that can react with it. So if you look at Q is a metal because Q can easily give out 2. All right. So Q can react with that because 2 can easily give out 2. P cannot give out 6. Look at the rest are non-metals because R want to receive somebody 1 to become octet here. So he's a non-metal. P is equally a non-metal because he wants to receive 2, a non-metal. S is equally a non-metal. He wants to receive 2. Then T is a noble gas. So the only person that can react with R is what? Is Q, because Q is what? A non-metal, a metal. Okay. So you will say that since, for number 5, say that since R is a non-metal, it forms ionic bond with it can form ionic bond with who? With who did I say that time? That is 2 comma 6. Who did I mention? I've cleaned it. With Q. Okay, it can form ionic bond with Q, which is a metal. All right, so this is very simple, and then we are done with that. So let's move to the next question. Right, so moving to the next question here. The next question said, what what is the what is the mass number, what is the mass number of an element if its atom contains 10 proton, comma, 10 electron, comma, and 12 neutron. Okay, this is very simple. Solution. So just know that mass number, like I said before, is equal to what? Proton number, if you want to use proton. Proton number plus neutron number. Neutron number. Now always use proton number, because if it is if it is an ion, electron will not work. But if it's a normal atom, a number of proton is the same thing as number of electron. As you can see here, that number of proton is 10 and the number of electrons is equal to 10. So this thing is a normal atom. So anyone you like is okay. So my answer is what? 10 plus 12, which is what? 22. So it has 22 neutron, 22 mass number. Right? Very simple question. So the next question here said, the atomic number, the atomic number, the atomic number of chlorine is 17. Now say, what is the number of electrons in a chlorine ion? Okay, very simple question. They said they said the atomic number of chlorine. So solution, we know that chlorine Cl has 17 electron. Okay, and chlorine atom has 17 electron. Then, and he always receive one, because if you write the electronic configuration here, you're going to have 2 comma 8 comma 7. So he needs one so that this man will attain octet. So when he receives one, he's going to be what? Minus here, and he will not change to what? 18, because he received one. Right, so you will not see that what? That the electron, the total number of electron he has now is what? Is 18. So therefore he has the ion has 18 electrons. That is 2 comma 8 comma 7. Right, so very simple. Or you just know that what? That M, any atom M, or rather Cl, normal Cl receiving 1 electron, he will now be what? Cl minus. Okay, because the more you are receiving electron means you are receiving more problem. So that is why you are always negative. So he is 17 plus 1 electron that he received, he will now be what? 18. So that is that. 17 electron initially plus 1 electron to become what? 18 electrons. So as simple as that. So the answer is what? 18. Okay. So the next one said, a hydrogen atom which has lost an electron, contains dash. Okay, the option, let me write the option. Contains dash: A, 1 proton only; B, 1 neutron only. C, 1 proton and 1 neutron. D, 1 proton, comma, 1 electron and 1 neutron. Okay, so solution. Now you know that hydrogen has 1 and 1. What do I mean by 1 and 1 is that hydrogen does not have any neutron. It does not have any neutron. So the mass number is equal to the same thing as the atomic number, and the atomic number is the same as the electron number. So once this man loses that electron, he has lost 1 electron. So he does not have any electron again. In fact, initially self, it does not have a 1 neutron. Okay. Let's check. 1 proton only. No, once he has lost one neutron, 1 electron, it means he has already lost 1 proton. Okay, so since he has lost already 1 proton, this one is not correct. 1 proton again, this one is not correct. In fact, the only correct one is what? Is B. The only thing he has now is what? 1 that is if we have H1 here plus. So which means since there is no proton, which means there is no electron, there is no atomic number. So the only thing that can make 1 here is the neutron, because mass number is equal to what? Proton number plus what? Neutron number. And since the mass number is 1 and then the proton number is 0, so automatically the only thing that can make this 1 here is the neutron number, that is 1. Okay, so the correct answer is B. All right, so let's move to the next one. All right, so the next one said it's a copy and complete the table below. All right, they gave us a table. Say particles. Particle. They gave us hydrogen. Say 1, 1. They gave us aluminium 3 plus 27, 13. They gave us oxygen 2 minus. They say 27, 8. So they now say we should complete this. They said number of proton. Number of proton. Number of electron. The number of neutron. All right. Okay. So now for this one, they gave us 1, 1 here. Okay, they are the one that decided to give us 1, 1 here. Now we know the formula. The only formula to use is that what? The mass number is equal to what? Proton number, proton plus what? Neutron. Okay, so now for the first one, we have that the proton number is 1 and the electron number is 1. And if you look at this, the one for hydrogen, number 1 for hydrogen, H11. Yes. Huh? I'm busy. H11 shows that what? Mass number is 1 and the proton number is 1. So if the mass number is 1 and the proton number is 1, automatically the neutron will be 0, because 1 plus 0 is what to make here 0. So here is what? 0. So now for number 2, aluminium, which is 27 here and 13 here. Don't forget they have 3 plus here. Now we are using the same formula, that this is what? 27 for their mass number, is equal to the proton number is what? 13. All right. Yes, 13 is the proton number, which is the atomic number. So plus the neutron number we don't know. So to get the neutron number, we now be what? 27 minus 13, which is what? 14, right? 14. Yes, 14. Okay. So which means the proton number is 13. Now, the electron number shows that because he is plus, means that he gave somebody 3. So if you remove 3 that he gave somebody from here, which means he will have 10 remaining for him. He gave somebody 3. That is the meaning of this 3 plus. Okay. Then the neutron number, we have gotten it to be what? 14. Very simple. So this one now, the atomic number, which is the proton number, is 8. But the electron number here is that he received 2. That is why he is what? Minus 2. So since he received 2, he will now be 10. All right. So therefore, he's okay, sorry, I have 16 here, not 27, 16, sorry. So his neutron number will now be what? The mass number minus the proton number. So we have 8 as well. So that is that. Very, very simple to work, right? So the next one, they gave us another table. They say that here is substance. I have A, I have B, and C. Then they say that sorry. Okay, it's not A, B, and C. Okay, they say particles. Sorry, particles. Particles. Okay, and they say that here is W2 plus. They say that here is X2 minus. Here is Y, and then the last one is Z. And the last one is what? Z. So they now say that here is number of neutron. Number of electron. The mass number. Okay, so they gave us here as 12, here as 24, here as 16, here as 27, here as 12, here as 11, here 13. I missed one. Sorry. You say it's number of proton. Why here is now mass number. Okay. So in the first line they gave us 24 here. In the second line they gave us 8 and 16. In the third line they gave us 27 and 13. Okay, so this is what they gave us, and they say we should copy and complete this. Okay, copy and complete this. Very, very simple. Now, normally this W seeing 2 plus, I told that if you are positive means you are a giver, you gave out. Okay, so first of all, let us get the proton number, because we know that mass number is equal to proton plus neutron. So the mass number is 24, is equal to the proton that I'm looking for plus the neutron they gave us is 12. So proton will now be what? 24 minus 12, which is what? 12. Okay, so the proton number here is 12. Now the electron will now be, he gave somebody 2, that is why he is positive. So the electron will now be what? 10, because he gave somebody 2. All right, so let's go to this one again. Because he accepted 2, that is why he is negative. He accepted 2, so if you add 2 to this one, you have 10 again. Are you getting it now? So now the neutron number should now be what? The same thing. Neutron number is equal to mass number minus proton number. So the mass number here is 16 minus the proton number is 8. So you now have what? 8 as well. Okay, so I have 8 here. So the same thing is applicable here. So now this is a normal atom, and in a normal atom, the number of electron is equal to the number of proton. So that is why we have 13 here. So the neutron number will now be what? Neutron number will now be 27 minus 13, which is equal to what? 14. So I have 14 here. So here, this one now is a normal atom. And in a normal atom, the number of electron is equal to the number of proton. So I have 11 here. Then the atomic number is now what? The proton number plus the neutron number, which is 2 and 3, 23. All right? See that this is very, very simple. Very, very simple. All right? So we'll move. Okay? So then I say, how many protons does 40Ca20 contain? Okay, very simple. Now this is Ca2040. The number of proton is same thing as the number of electron, which is same thing as the number of atomic number. So the atomic number here is 20, so it has 20 proton. So if you want to get the neutron, you will say that 40 minus 20, which equal to 20, it equally has 20 neutron. Then the mass number is what? 40. This is very, very simple. This is a very simple question. Right? Okay, this one said that the relative atomic mass of some elements are not whole numbers because different atoms of the same element may have one. Okay, let me write that. The relative atomic mass of some elements are not whole numbers. Now whenever, because different atoms of the same elements may have different mass number due to different number of neutron. In fact, I don't need to write the rest, but that is the answer. Why? Because whenever the relative atomic mass of an element is not a whole number, that is, it has point or is a fraction, it is due to the fact that that element has an isotope. And what is the what brought about an isotope is because they have the same atomic number but different mass number. Okay, the one down is always the same. For example, maybe 10 here and 5 here. Then I have B 5 here and 12 here, something like that. You see that they have the same atomic number but different mass number. And what brought about different mass number is because they have different neutron number. Okay, so the reason is because they have different mass number due to what? Different neutron number. And what does it mean? They have an isotope. Okay, so A is the answer, even without doing anything. That's a very simple question, right? So the next question here said, which it said which of the following noble gases has electronic structure similar to that of N in in NH in NH3 in NH3, right? Okay, so if you look at this solution, which of the following noble gases has electronic structure similar to that of NH3? That is how it's supposed to be. That of, not that of N in NH3. Okay. Now, if you look at this, you see that NH3, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. Now, nitrogen has seven atomic number, or seven electron, or 7 proton. So for this is N plus 3 of H, which is what? 7 plus 3 into 1, which is what? 7 plus 3, which is what? 10. So the total number of electron there is 10. Okay, so which element has 10? You count: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So neon has 10 as well. So Ne has 10. So neon has the same electronic structure, because since they have 10, the electronic structure will be 2 8 10. So this one will still be 2 8, the same 10. So they have the same electronic structure. All right, so that is that. So the next question here said, which which of the following which of the following species correctly represent an ion of M with 13 proton and 10 electrons? Okay, even without writing the option, very simple. So this metal, okay, how do we know that it's a metal? Because I already know that he lost 3 electrons. That is why he's remaining 10. Okay, this metal has 13 here, but it is 3 plus. Why is it 3 plus? Because the total number of protons supposed to be the total number of electron, and the proton here is 10, and the electron is the proton is 13, and the electron is 10, which means they gave out 3. He gave out 3. So since he gave out 3, it is now 3 plus. So that is the answer. Okay, 13 is the normal atomic number, which is number of proton. So with 3 plus here. So this is the answer, even without solving anything at all, even without seeing the option self. That is the answer. All right, so the next question said, which of the following ions, okay, has the electronic configuration 2 8 8. Okay, solution. Now, which of them has 2 8 8? Now, the option, okay, let me write the option. Option A said Na plus. Option B said Mg2 plus. Option C said F minus. Option D, option D said Cl minus. Okay, so let us write the electronic configuration of these atoms. For A normally sodium is 11, Na 11, because hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium. So sodium is 11. So because it is plus, it means he gave out 1. So if he gave out 1, he will now be 10 electron. So the electronic configuration there should be what? 2, 8, 2, 8, because it is 10. Okay, he gave out 1. Okay, so for B now, magnesium, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, 10, sodium, magnesium. Magnesium is 12. So which is what? Mg12. Neon, sodium, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium. Magnesium is 12, and 12 is what? Since it is 2 plus, means he gave out 2. So it is the same thing with as the 2, 8, because he gave out 2. So look at C. C, fluorine. Fluorine, we can count it: hydrogen, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Fluorine is 9. Fluorine is 9. That is Cl. Sorry, fluorine F, which is 9. F, which is 9. But he accepted 1 to make it 10. So he is 2, 8. You see, automatically the answer is D, which is chlorine. Cl minus. Chlorine is 17. Because he accepted 1, he will be 18. That is what? 2, 8, 8. I knew it is D, but I just want to use A, B, C, D to show you how it will look like. So the answer is what? Chlorine. Is chlorine that has the same electronic configuration as that. Okay, so the next one here said where is the next one? Okay, the next one said, number one said, distinguish 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 between atomic number and mass number of an element. Number two said, explain briefly why the relative atomic mass of chlorine is not a whole number. Okay, this is a very simple question. First of all, the difference between atomic number and mass number. Atomic mass number is simply atomic number plus neutron number. That is the easiest thing. So the difference is that atomic number is bigger, and it is written as the superscript of an atom. Sorry, the mass number. Mass number is bigger than what? Atomic number. And atomic number is used to determine the chemical properties of an atom. You cannot use the mass number, because atomic number is used to write the electronic configuration of that atom. So since atomic number is used to write one, atomic number can do so many things. One, atomic number is used to write the electronic configuration of an atom. Two, atomic number, since it is used to write the electronic configuration, it tells us the period and the group of that atom. Three, it tells us the chemical properties of that atom. So, but mass number cannot do that. Then for mass number is simply atomic number plus neutron number. Okay, so that is the difference between them. So number two said we should explain briefly why the atomic number of chlorine is not a whole number. Why? Because chlorine has isotope. Okay, we have isotopes of chlorine. So because the only thing that can make an atom not to have the atomic number as a whole number is because of the presence of what? Different mass number. Chlorine Cl has 17, 35, and again Cl 17, 37. So they have the same atomic number, but different mass number due to the presence of different neutron number. So that is why it has the atomic number as not whole number. Okay, so the next one, and let me check my time. Oh, so thank you very much for watching. Please like, share, and subscribe. Bye bye.